Hey guys, Miss Martin here, and today we're going to continue with operations with complex numbers. So yesterday we had learned that the square root of -1 was known as this imaginary number I standing for imaginary. And we had also talked about what happens when we take I and we square it. Well, that's where we take the square root of -1 and multiply it by the square root of -1, and we get an answer of -1. So now let's think about I cubed. Well, I cubed is going to be the same thing as I squared times I to the first, because we take the two exponents, the 2 and the 1, and add them together, and that's how we get I cubed. We break it up because I squared, we know from previous, was -1. -1 times I is going to give me -I. Now we're going to do I to the fourth. So that's I cubed times I. I cubed we know is -I. -I times I is going to give me -I squared, which is going to give me a +1. Oh, we're going to continue with this pattern. So we're going to do I to the fourth times I. I to the fourth we know is 1. 1 times I is just regular old I. Do this once again. So I to the fifth times I is going to equal I to the fifth is I times I squared is -1. What do we notice here? It looks like I squared was the same thing as I to the sixth. Also, if you noticed, I to the first was the same thing as I to the fifth. It looks like every 1, 2, 3, 4 powers of I, the answers are going to repeat. And so there's a little bit of a shortcut that we can remember. So for our shortcut, instead of deriving the powers of I just like we did every single time, I like to say, think about you're running a race. And at the end of the race, you're so excited you exclaim, I won! I won! And then put 2 negatives in the middle. This is what this is going to stand for. I is I to the first. -1 is I squared. -I is I cubed. And 1 is I to the fourth. Since this pattern repeats every 4 times, we're going to divide by 4, and then the remainder is going to be your answer, or your power of I. So for example, if I wanted to do it with I to the 6, I would say, okay, 4 divides into 6 one time with a remainder of 2. So I to the 6 is equivalent to I squared, which is equal to -1. I would take 32 divided by 4. I get 8, remainder 0. So I to the 32 is equal to I to the 0, and anything to the 0 power is 1. I would take 101 and divide it by 4. So I get 25 with a remainder of 1. So I to the 101 is equal to I to the first, which is just I. You can try these next few examples on your own. So if you would like to pause your recording, you can, and then check your answers with me. So we're going to take 42 and divide 42 by 4. When I divide 42 by 4, I'm going to get 10 with a remainder of 2. So I to the 42 is the same as I squared, and I squared is equal to -1. Now I'm going to take 127 and divide it by 4. So I'm going to get 3, 12, 0. This goes in once with a remainder of 3. So I to the 127 is equal to I to the third, which is going to equal -I. And this one you guys can try as a bonus on your own. The next section we have is complex numbers, which we were talking about yesterday, come in this form A plus BI, where A is our real part and BI is the imaginary. So right here, 7, well, I would say it's 7 plus 0, I. I would say the square root of negative 16, well, that's going to be 0 plus 4i. For this next one here, let's simplify underneath the square root. So I'm going to have 4 minus the square root of negative 17 minus 49. So let's do that. So negative 17 minus 49 is going to give me negative 66. And the square root of negative 66 well, does that simplify? Let's think about this. Doesn't look like the square root of 66 is going to simplify, so I'm just going to get 4 minus I square root of 66. Let's apologize about that pen right there. For this next one, it looks like I'm going to have a negative out in front. The negative underneath that square root is going to mean I'm going to have an I. The square root of 125 is going to be 5 square root of 5 all over 3 minus 15. We always put our real part first. So I'm going to have negative 15 plus 5 square root 5, 3i. And yesterday we had went over adding and subtracting complex numbers. So once again, try these on your own. And then if you would like to pause your recording and then check my answers. So I have 8 plus 25. That's going to give me a real part of 33. And then I'm going to have an imaginary part of 11 plus 28. So I'm going to get a plus 39i. For this next part, let's expand this out. So I have 13 minus 23 minus 7i minus 25. Combining my real parts, 13 minus 23 is going to give me a negative 10. Oh, minus 7i minus 25i. Forgot the I right there, but I'll keep that together, no worries. Negative 7 minus 25 is going to be negative 32. So I have negative 10 minus 32i. Okay. Multiplying complex numbers, well, we would treat this like we would with any binomial, and we are going to just FOIL. So I'm going to do my first, distribute the 3 to both terms. So I'm going to get a 6 minus 18i plus 8i minus 24i squared. Okay, so I get 6 minus 10i plus 24. The reason why I was able to do that is because I squared is the same thing as negative 1. So negative 24 times negative 1 is going to give you a positive 24. Add my real parts, so I get 30 minus 10i. The next part, I'm going to do the same thing. I'm going to multiply my values. So I'm going to get 3, and then it's going to be a minus 8i. Then it's going to be a minus 18i. And then it's going to be a plus 48i squared. Now I'm going to combine my parts. Once again, we'll remember that I squared is the same thing as negative 1. So I'm going to say, okay, well, that's really like a negative 48 plus 3. So negative 48 plus 3 is going to give me a negative 45. And then I'm going to have my negative 8 minus 18. So minus 26i. And I apologize for the handwriting on that part. My cursor was moving way out of the same proportion as where I was supposed to be writing. And guys, this next one, oh man, this is going to be a doozy, I tell you. Let's start off by just doing the first two parts right up there. So let's just multiply those two together. So I have 2 plus I times 3 plus I. So here I'm going to get a 6 plus 3I plus 2I plus I squared. I squared is the same thing as -1, so I'm going to get 5I plus 5. Let's just kind of move this around just to make sure my things are looking good. Now the next one I'm going to say, okay, so I have 2 minus 3I, and I'm also going to multiply that by 5I. So the next step I'm going to do is I'm going to say I'm going to do this portion right here and FOIL those two numbers. So I'm going to do 5I times 2, so I'm going to get 10I. 5I times 3I, so minus 15I. Then I'm going to do 5 times 2, so I'm going to get a plus 10. And then a 5 times a minus 3I, so minus 15I. Then the next thing I'm going to do is, let me just double check to make sure that was good. So I get a 10I, 15, oh man, a 10I minus 15I, 10. So 5I, 15I. Okay, let's just double check. When I was double checking, this should be an I squared. So let's just make note of that. And now when we're looking at this, I'm going to get my real part, I squared. Remember, I squared is the same thing as a -1. So this really, let's just get my pen back looking good. I just need to scoot this up, scoot it down so it's nice and oriented. Okay, so that's like saying 10I. That's going to be a minus 15 times -1 plus 10 minus 15I. So that's going to really be a 25 minus 25I. And now I still need to do the final portion, which is to multiply it by the 5I. So finishing this on up, 25 times 5 is going to be 125. So I get 125I minus 125I squared. And we all know that I squared is the same thing as -1, so it becomes a positive 125. And then it's going to be plus 125. There we go. So hopefully we're able to look at that. 15 is a doozy. Make sure that you are able to do a question like, let's just scroll up, just trying to keep this nice and focused for us. Make sure you know how to do 13 and 14, 13 and 14. Number 15 would be a more of a challenge style question. And the last type of problems we have is where we're dividing with complex numbers. And so the first tip I would say is when we're dividing with complex numbers, I would make sure that I rewrite it so that it is looking like an actual division problem. So take that division sign and rewrite it as a bar. You'll remember from our last unit something called a conjugate. So that's exactly what you want to do. We want to find the conjugate of 5 plus I. So if we remember about conjugates, they are the same two numbers. So it's going to be still a 5 and an I. But instead of having a plus sign in between, we are going to put a minus sign in between.